So you see, guys, there are in the review 50 questions. I highly recommend that you go and look through all the 50 questions. And first and foremost, recognize where you have weaknesses. Understood? You should go over all the materials that was presented in some lectures long ago. In my notes, you can read all of those things. All right, so here is a first question. Limit as x goes to -7 of f of x is 4, and the other one is 6. Then tell me, what is this limit? And we will also work on how to input information. You see, guys, you don't want to work harder than you have to. So you don't need to submit the answer. You might not need to solve anything. All right, this is an easy question. Yes, guys, so I'm just gonna try to answer it. So look at it, it's 4. So I'm not even gonna bother doing the operation. So I'm gonna write just 4 times 7, sorry, 4 times 6 minus 8 times 4 and plus 5. Let's see if it gives me the score. So it's 4 times 6 minus 8 times 4 times 5. What does it want? Maybe it doesn't understand multiplication, but regardless, it's an easy question. No, not why 8 times minus 7. Ah, yes, 8 times minus 7, that's correct. I forgot it's this, right? Times minus 7, thank you for correcting me. Now it should give me the right answer. Yes, you see, guys, the point being is that you don't need to spend time on calculations. Understood? So don't waste your time, answer the question very rapidly, and let's move on. Okay, let's move to the next question. It's the same, you agree? Do I need to put it in, or you understand how to solve this question? So we can move on. What do you mean skip to the actual finals? That's a review for the final. Well, so if you saw the review and it's easy, maybe the exam is not going to be terribly difficult. Congratulations then. So this question you all see how to solve, correct, guys? I don't need to do this. You just put the division thing and whatnot. This question I also can do easily. I don't really need to explain it to you, correct? All right, here is another one. I also don't need to do anything here, correct, guys? You understand how to do the input. It's a very simple question. Am I right or not? Let me know if I'm skipping too much for you. You understand that you don't even need to carry out the calculation. You just need to be careful and input the information correctly. Like you can make careless mistakes because it's so boring, like I did. Good. I mean, what really happens is simply look at this, right? So what happens? X goes to 7, doesn't matter. What happens is that f of x essentially becomes 5. So wherever you see f of x, it's 5. Wherever you see g of x, it's 1. And then you can just place the answer. Yes, you don't even need to calculate the number. Just you need to write this expression with f replaced by its value that it approaches and g replaced by the corresponding value that it approaches. It's as simple as that for those questions. Good. If you want to, you can put a number, but you see what's fastest. You understand, guys? You put it on paper. Always, you see, how do you prepare for this exam? Have a piece of paper, be able to write your calculations. Maybe have a separate piece of paper where you input your work. You would have to upload your work. Yes. All right, so what about this one? F of minus 2 is 0, limit as you approach from left and right is given here. Which of the following graphs give me that information, guys? So satisfy this information. Please let me know what I should select. I want lots of comments, I mean, for this question, it's it. The last one, okay. And what about the rest of you guys? It's a simple question or not? You should right away look at it and tell me what's the answer if you understand it. Left 2, this one. Second, the left, so you're saying this one, yes? Okay, let's see. So at minus 2, it's 0. And then minus 1 and minus 2, that looks like this one. I agree with you. Left 2. Wonderful. Next question. Y is what? For this question, look at it. F of minus 2 is 0. You look at the graph, at minus 2, I should see 0. So this is minus 2, I should see 0. Where do I see 0? Here, 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 and here. Yes, this is already excluded. Then I see limit as I approach minus 2 from the left. From the left, it's minus 1. From the left, I should see minus 1 here. From the right, I should see a lower value, minus 2. That's satisfied. Over here. Everybody sees it? You just, it's basic limit that we did in the beginning of class. All right, onwards. What about this one, guys? Which of the graphs match this situation? If I approach infinity, I get to 5. If I approach to minus infinity, to 3. And minus 2 from the left, it's minus infinity, and that plus infinity. Look at those graphs. So again, you can even draw a picture. To the right, it's 5. To the left, it's 3. And at minus 2, I have an asymptote. Minus infinity from the left and plus infinity from the right. Which graph corresponds here? Hmm? You remember? 5, 3, minus infinity, infinity. Which graph corresponds? Very good, the bottom. Absolutely right. It's the bottom graph. Last graph, agreed? We have asymptote at 5, they're done. Everybody says, what is this? What does this mean? Plus, when I go to plus infinity, I get 5. It means that the graph looks like a horizontal line. Remember that? Question 7. What does it look like is the limit as x goes to minus infinity? Very good. The answer is 1. Very nice, isn't it? Let's hope the question gets much more interesting, yes? It's a very easy question, too easy. So what about this thing? So here we want to know what happens as x goes to minus 2 plus, and what happens as x goes to minus 2 plus. X goes to -2 plus, what happens? Okay, okay. So the answer is, okay, what is -2 plus? It's over here, right? -2 plus is going here, and it's infinity. So how do you put infinity? We put this thing and submit, and wonderful, we have it right. Yes? X going to 1 minus, what do we approach? X goes to 1 minus, what do we approach? 1 minus, what do we approach? Very good. The answer is obviously, and you can just look at it. How is it? Can it be approaching 3 if it goes up? So it would be infinity. Yes. What's there to get? You're at 1. You're approaching from the left. So where are you located? You're located here, and you walk towards. You see here. You walk your x-axis towards 1. Where are you climbing? You're climbing up. Yes. Very simple. You put your mouse on the curve, and you walk towards 1 from the left. This means walk towards 1 from the left. The x coordinate walks towards 1 from the left. What happens? You're climbing. So what's 1? The x coordinate is going to 1, but the actual question is about f of x. What's the limit of f of x? So f of x, that's the y coordinate. It's y equals f of x here when you draw a graph. So the limit of the y coordinate is infinity. The limit of the x coordinate is 1, sure. X approaches 1, but the y coordinate is what we're asked about. It's approaching infinity. All right, here is another thing of that sort. Didn't we have this? It looks like a repeat of a previous question. It was stuck here again. And we know how to solve it, correct, guys? So question 11. Following graphs exhibit whatever properties. You tell me which graph matches. So we have this. Okay. First one, very good. The answer is first one. Good. Why what? So we have, okay, as x goes to infinity, it's 2. Is it happening? If x goes to infinity, does it look like we are approaching 2? Yes, it does. -2, it's undefined. And so there should not be a black dot over -2. So it eliminates already a few graphs. And then the limit as x goes to -2 is infinity. So as you approach -2, you get infinity from any direction. Yes? You see that? Whoop. So you just picture the graph then. So if you approach -2 from the left, you're walking from here. Your x-coordinate approaches -2 from the left, you climb up. Approaching -2 from the right, you climb up. Here is another one. So here you have y is f of x solid and gx is the dashed line. You need to answer the following questions, guys. So what about limit as x goes to -4 minus of the ratio? What is that equal to, please? We're approaching -4 minus, and we want to calculate the ratio. I want to tell me what would that be. Come on, guys. You have multiple choice options here, as you can see. -4 minus. You approach -4 minus. What is the ratio f to g? From the options given here. -4 minus. So let's look at it, guys. You're saying doesn't exist? Well, it's somewhat true, but you can say better, right? So this number is 3. F approaches roughly 3.5, something like, I would say F approaches something like 3.5 plus. You see, because I'm walking from the left, right? And as I approach -4 from the right, I am from the left, sorry, I am at a -0. Do you agree? It's a -0, which makes this minus infinity. It's true that that means the limit doesn't exist, but among the options available, minus infinity is a better answer. Yes? So the answer is minus infinity. Do you understand what I did, guys? I just looked at f and I say, okay, if I approach -4 plus, I mean roughly 3.5. It doesn't really matter what this number is because it's divided by a -0. As I approach -4 from the left on the dashed line, I approach -0 with a minus. So some number always smaller than 0. So the ratio of positive to negative will make a negative number. And because it approaches 0 in the denominator, it will be negative infinity. Yes? So let's select it. Minus infinity. It's for a one-sided limit here, yes. So then they are asking for the next limit, right? So now we are approaching -4 with a plus. What do we say if we approach -4 with a plus? We say, and I want a lot of answers. Okay. Positive infinity, agreed? So you select positive infinity. And what about the limit as x goes to -4? As x goes to -4 is what? Very good. Doesn't exist. Yes? All right. And lo and behold, we did not make a mistake. Good? Any questions? You understand how we solve this problem? Here is your next one, okay? Two curves we have intersect at 3, 0. You see the graph y f of x solid and y g of x dashed are shown. Two curves intersect at 3, 0. So this is 3, 0 here. Determine the sign of the following limits. The sign f of x times g of x, the sign of this limit as x goes to 3, Is it going to be positive, negative, 0, the sign of the limit? The product f times g would be what? All right, 6 answers, it's not 20. What's the answer for x going to 3? I think plus, plus, plus. So what happens as x goes to 3? Tell me what's happening here. What's happening? It's 0. 0. Next, as x goes to 0, f of x times g of x, what's the sign? Because look where it is. You multiply two numbers, they're intersecting at 3, 0. So the intersection is, you approach g as approaching 0, and f is approaching 0. What could it be? What sign could it be if you take the product? It's like you take two numbers that are essentially 0. So you multiply 0 times 0. What are you getting? What sign is it going to have? It's going to be 0. Among these options, it's just 0, right? And now let's look for 2. The sign, guys, you see? So both, so we take the product f times g. What's going to happen in here, please? As you approach 0, look at it. We approach, so x is approaching 0, and here it is. And g approaches 0. What's the sign? Come on, more comments. I want to see what you think. You see, you have 3 options. So among those options, what is it going to be? I see there is a deliberation. What happens to the black line? As x goes to 0, what happens here? It approaches to negative or positive number when I go to 0. For f, negative or positive? For f, negative or positive? Negative. And for g, also negative. Negative times negative makes a positive. Yes? Negative times negative makes a positive. So let's look at our work. Wonderful. What a surprise. How is it negative? I mean, look at it. It's below the x-axis. Both f is negative and g is negative. The product is negative times negative, which is positive. Yes? All right. According to the definition, so here you have to enter limit in reduced form. So f of x is minus 4x minus 2. F prime is limit as h goes to 0 of what? What do we put here? The derivative at x. So we simply put, I don't know what they mean. So enter limit in reduced form. Enter limit. Yeah. So what is it going to be here, guys? Well, very clearly we should have here an h. They want an h here. So then here we have minus 4 x plus h minus or simply plus 4 x, right? And hopefully that's a syntax error. Okay, I don't know what they want from me. What syntax error? And this would be what? Simply would be -4, right? Let's see what happens there. What syntax error I'm trying to understand. Will be work, enter limit. So f prime of x is -4. And here you add work. And what is this? What is this? -4 for both. Maybe you're right. Let's try -4 for both. Let's see what if it worked for both. If you put -4, I know what they wanted, but whatever. The h is the error. Yes, I mean I guess it didn't want the h. It wanted you to remove the h, I guess, which is in this exercise really silly. Yes. So onwards. Well, this one is a bit more interesting. You see, a bit more conceptual. Let's see how we solve this one. So graph is yf of x, yg of x is dashed. So this is dashed, this is solid. Curves intersect at -5, 0. So this is -5, 0. Yeah. They are asking whether this limit, look at it, this limit is positive, negative, or 0. Is this limit going to be a number that's positive, negative, or 0? Okay. Look at it and tell me, please. I'll wait, and I want, how many people do I have here? 24, guys. I would like 20 answers. So let's see how many answers I have. Only 11 so far. A few more I'm waiting, guys. 11 answers, why not 20? You can even zoom in, I think. Say you can do this if you need to zoom in. I don't see why you need it, but fine. Positive, negative, or just a very simple question. Look at the curve. Do you see this curve? This curve is made of linear tiles. Do you agree? Now near this point over here, near -5, how is the tile oriented? It's oriented like this. This is how it's oriented, and that has negative slope. As simple as that. So the answer is negative. What about the second one? What's the answer, please, for G? Also negative. Very good. Here is another one, guys. At 2, what can you say about the limit as h goes to 0 plus of this thing? As h goes to 0 plus of this expression, what can you say about the limit? Positive, negative, 0, or undefined? As h goes to plus. You see, h is going to 0 plus. Positive, 0, or undefined. As h goes to 0 plus, positives, negative, 0 are defined. Look at it. What does it mean to h going to 0 plus? What's happening? Look at this curve. All right. And the answer is obviously positive. Look at it. If it's h plus, that means that I'm approaching, my second point is here. And I measure the slope from this black point to the red point. Do you agree? And the slope from the black point to the red point is naturally positive. You can see that. What about, let's see, okay. Francis, what, for instance, when you say h going to 0 plus, 2 plus h is the second point. What do you do to calculate slope on a line? You take 2 points. One point is this black point. 2 points meaning it has the x coordinate and y coordinate. The second point is given by 2 plus h, f of 2 plus h. And that point is here, right? This is the point. Yes? So between the red and the black point, this measures the slope, and the slope is positive. What about this part? H is approaching 0 minus. Is it positive, negative? What is the slope, or whatever else is written there? Negative, yes, because if you take this point here now from red to black point, there is a negative slope. Negative. And the limit altogether? The limit altogether is what? Okay, the limit altogether, guys, look at the shape. Just think about it. Would you like to pet this curve? Is it like a nice curve that is smooth, sharp, right? So you can get caught, you can get yourself caught. So this is undefined. Yes? All good? Guys, think concepts are very simple. Slope is just you calculate 2 points. So why is it called calculus? Because it is the study of calculating something small, I think somebody said, right? So calculus means calculations of small things. What are the small things we're calculating? Well, small slopes, so a small line segment slopes. All right, here is another one. f of x and f prime have the values that you see over here. And then we have g is f 4x squared minus 2x minus 53. So it asks you to calculate g prime of 5. Yes? G prime of 5 from the information of f. How do they even want you to put the g is this thing? Okay, yes. G is f 4x squared. This is g. Okay, so we want to understand what is g prime of 5, please, fast. Oh, good. Maybe. What do we have here? We have this expression. So you just evaluate first of all what is f at that when you plug 5. So 4 times 5 squared minus 2 times 5 minus 53. Yes. So what do we have here? So altogether. This is 100. So it's 100 minus 10 and minus 53. So yes. So we have this number, and that's for f. It is what? What is this number? So it's 100. Minus 10 minus 53, so that's 100 minus 63, and that's what is it? 37, right? So 37 is our number. So 37, f of that number. So f of 37. Is minus 7. Agreed? F of 37 is minus 7, and f prime of 37 is what? It's minus 6. Yes? So what do we write here? We can write here simply minus 7. So g is just f of 30. G is equal to f of 37. So it's so sorry, not minus 7. So we want to take g prime of this value. So g prime of, so that would be f prime of 37. So it would be minus 6 multiplied by f prime of 37. So by minus 6. Yes? So it's minus 6 times minus 6, and that's 48. No? I think 36, I mean. So let's see. Yeah, so just to be careful, guys. So the derivative of g, so it's this, right? So it's g prime evaluated at this number inside. I made a mistake for the second one. G prime of 37, which is f prime, so times the derivative of the inner thing, which is I made a mistake here, which is 8. 8 times 5 minus 2. Yes, so I made, of course, a mistake with the second one. So it's f prime of 37 multiplied by 8 times 5 minus 2. Yeah, so it should be here. Let's correct it. It's times 5 minus 2. Now I think it should work. Yeah. Understood? Just be careful. Good? Explain. There will be another like this. What's there to explain? So just look at this question. This is my function, right? So the chain rule is this: g prime of x is the derivative of f composed with this function. So it will be f prime of 4x squared minus 2x minus 53 times the derivative of the inner function, right? I took the derivative of the outer function. Derivative of the inner function is 8x minus 2. Yes. Now, what is that? So we are getting f prime in this particular case because x is 5. So it's f prime of 4 times 5 squared minus 2 times 5 minus 53 times 8 times 5 minus 2. Now, this number over here is 37. So we have f prime of 37 is minus 6. So we have minus 6 multiplied by 8 times 5 minus 2. And that's how I got my solution. Because it's chain rule, Francis. Why did I take the derivative of the inside? Because that's what you do when you apply chain rule. Right? Don't forget how chain rule was established. Good? Ready to move on? All right, here is another one very similar to the same idea. Guys, solve it. Okay, well, let's wait. Come on, guys, should be lots of answers. All right. Good. Let's hope it's good. What should it be, guys? Very simply, derivative g prime x is f prime of x divided by 2 root f of x. You agree? I apply chain rule. Derivative of the outer function is 1 over 2 root of what's inside times derivative of what's inside. So then I want it at 17. So my interest is f prime of 17 divided by 2 root f of 17. So I look into this particular column. And what do I see in that particular column? I see that the derivative is minus 5. And on the bottom, I have 2 root 10. So it's minus 5, 2 root 10. Good? Understood, guys? Not too bad, right? Here's another one of the same sort. What's the answer? And guys, of course, as again, it would be nicer to see your faces. So turn the cameras on, it's boring. I only see the top screen. Now, nice to see you, Christian. All right. So you get a bunch of numbers. Let's see what we put in, guys. Again, avoid doing unnecessary calculations. Avoid doing, oh, hello, David. Nice to see you too. Avoid doing unnecessary calculations. What is that? What is happening here? So you need to have the derivative of this function. So it's 4 f x to the power of 3 times f prime of x, yes? So then at what number? At 26. So we just look, we have here what? F of, so I look at this column. 26, yes? So f of 20, so what I have is 4 times 26 cubed. Yes, times the derivative, which is times 3. And that's what I will write here. So 4 times 26 cubed times 3. What's that? What's the... right. My apologies. It's 5 cubed, right? I mean, thank you for. I suppose you're writing to correct me, guys. Yes. So it's 5. I accidentally wrote 26, but you should write 5. Now it should be good. So be careful, guys. Yes. When you do this, do it on paper. Be careful that you put the right input. Understood? The only difficulty, I think, in those problems is that you can be so bored that you will make a mistake with it. Yes? That's the challenge. So, I mean, if I give you problems, then of course you cannot be so bored. I can give you such an interesting problem that boredom is just not an option. Yes? Okay, 1 over f of x. Again, another question of the same sort. Quickly tell me what to write, guys. And the answer is, so the derivative is -1, minus, you can just write it f prime x divided by f squared x. Yes, that's the derivative. Now, which column we're interested in? We are interested in the 45 column. Yes. So just so I avoid making that mistake as before, it's -3 on the top. Not minus, yes, -3 on the top because we have a 3 here, and on the bottom it's 4 squared. So let's put it like, we can of course calculate it as -3 over 16, but you understand, guys, in general you can just you can write something like -3 divided by 16 if you want to, or this is the 4 squared. Wonderful. Good. You understand how to solve this question. This is like the third or fourth that we are doing. Yes. Why f prime, Francis, again, chain rule. What's happening here? It's f of x to the power of -1. What happens when you take the derivative? It becomes minus f of x to the power of -2 times the derivative of the inner function. It's chain rule. That's why there's and I wrote it simply as minus f prime x divided by fx squared. Yes? Very good. Next. When are they going to be over, right? So this one, do we need to continue with those questions, or you got the idea? Let's see how many of those are going to be next. Okay, this one is the last, so let's do it. All right, so what do we write here? We select which column? We select the column corresponding to -2. Here it is. And what do we put in? The derivative is minus 5f prime x divided by fx to the power 6. Yeah. So what do we put in? We put in this minus 5 times minus 4 to the power of just that times minus 4 divided by minus 3 raised to the power of 6. Wonderful. Here is another one, guys. Calculate dy dx, please. This is your function, calculate dy dx. Okay, interesting. Don't forget, guys, that you will need to add your work when you do the exam. So focus, what you do is when you solve it, have a clean sheet of paper that you can upload. We will get there. We will see what we do, guys. Ah. Right, good. We solved it. The answer is like this. This is the answer. You understand what you do, guys? Yes. So how is it done? Slowly, just you have 2y y prime plus 15x squared is equal to 8y prime minus 18x. Yes. And then you just group the y prime. So what do you have? You have 2y minus 8 times y prime is equal to minus 15x squared minus 18x. And so what do you get? You get that y prime is equal to minus 15x squared minus 18x divided by 2y minus 8. Agreed? Here's another one. You need to find y prime at 5, 5. It has to be a number at 5, 5. All right. Here's, guys, I mean, this you have to practice. What's the solution? We know that y prime is equal to minus, and here we have 3f squared x times f prime x minus 10y, and on the bottom we have 3y squared minus 10x, and we plug in the particular values, right? So what is that? This is minus, here we have 3. We have 3. At 5, we look at this column. So 3, f of 5 is 4 squared, so 4 squared times 8 minus 10 times 5. And for the bottom, it's 3 times 5 squared minus 10 times 5. This is my formula. Yeah, let's try to put it in. So minus 50, on the bottom it's 3 times 5 squared minus 50. Wonderful, we did it correctly. Good. This is what you should get, guys. And how do you practice? Well, you practice doing this process so that you're able to quickly take the derivative. I taught you shortcuts even. You can look at the notes. Okay, so next question. Here's another one like this. I don't know. I mean, I will try to get as much as possible covered. I'm trying to see if I can get close to 50 questions answered. Yeah, so we can be done with this forever. In one sitting, yes. All right, so afterwards, guys, when you do the questions on your own, you can just play my video if you need to along, solve the question, see if you're stuck somewhere. You should be able to solve those questions rapidly. So what's the answer here? Derivative of, we already did this type of question. You see f prime, so this is simply f prime x over fx. And we're interested at 38, so we are interested here. So we are going to write simply on the bottom it's 4 and on the top is 3, so it's 3/4. We are done with this one. Let's move on. Here is another one, guys. We understand how to solve this one as well, yes? I mean, I can just quickly write it, yes? We solved this question already a bunch of times, so this would be, how do you even write exponential functions? So we put e to the power of 13, so f of 13 is 10. Power of 10 times derivative at 13 is 7. And we're done there. No, the exam is fewer questions, not 50, I think. But probably it will include one question from each category, right? We see the same question repeated many times. So those that are repeated frequently might be on the exam, you should know them cold. Here is something more interesting. All right, so 26, suppose that in the interval from x7 to 17, you know that the graph of x falls as you move from left to right. Okay, and the graph is concave down. So this, for concavity, look into my videos from the semester that I showed you, right? The semester where I told you to look at integration. We will see what we go afterwards, right? We need to try to finish this thing and then deal with it. Okay, guys, so just a brief reminder, guys. So if in case you haven't read, so concave up is this type of shape. Yes, it's either this type of shape or this type of shape. It means that second derivative of x is positive. You understand? The first derivative you can see as the slope here. Second derivative is the tendency of the slope to become more positive. Okay, so that's concave up. Concave down is when the derivative is like this. So that's concave down. That's when the second derivative is less than 0. Understand? So that's the tendency of the derivative to try to become more negative. Regardless of what the derivative, first derivative is, if it's tending to be more negative, that will imply that second derivative is negative. Yes? All right, so let's try to see this question. So x is from 7 to 17. You know that the graph falls as you move from left to right, and the graph is concave up, which means you can imagine it's like an airplane diving and trying to correct the dive. So this is the shape, okay? Like this, right? So so then what will you know? So the graph is concave down. I don't know, sorry, as you move from left to right, the graph is concave down, so it means actually that the dive is stronger. Assume f and all its derivatives exist for this interval. Select the correct answer. F of 14, f of 15, guys. What do I select? So f of 14 clearly is greater than f of 15. Do you agree? Because we're saying the graph is falling, so we're diving. And concave down means that I'm diving ever faster. So then f prime of 14 compared to f prime of 15, guys. What's the comparison of the derivatives? Which derivative is bigger, at 14 or at 15? Exactly, 14 is bigger. You see, because concave down means, guys, that the second derivative is getting negative, which means that the slopes are getting ever more negative. If we're falling, slope are getting negative, and we're in falling faster, they're getting more negative. Yes, so the answer is greater than again. Now this limit at 14 and 15 is the same question as before. Greater than f14 compared to 0. So what do we know about this graph? False, we don't know anything about the comparison. So f prime of 14 is less than 0 because it's a negative derivative. Yes, so let's see if we made any mistakes. No, we made no mistakes. Good. Isn't it amazing? I hope you understand it, guys. I did not go over concave up, concave down, even though it's part of lectures I advise you to watch. But it's very simple. Y is less than 0 because we have negative. Look at it. At 7 and onwards, the graph is falling, which means that the slopes are negative. And if they're negative, they're less than 0. Agreed? So they're saying it's just annoying to read it, guys, but they're saying the graph is falling, and they're saying it's concave down, which means that you're falling faster and faster and faster. You see, so the slopes are not staying. To fall, they have to become negative, but to be concave down means that the slopes are falling faster and faster. They're becoming more vertical falling. Yeah. So you just think of the song "Falling, Falling." Do you know the song? Falling, falling, something like this. I cannot sing it. I can find it for you. All right, here is another one. All right, the graph of y of prime is shown. Where is the maximum of the graph of f of x, relative maximum at what value? So let's look at it, guys. This is the graph of slope. So that means that the slope is you have to be careful, guys, right? So this is the graph of slope. So the slope is to be maximum. Think about it being blind. If you're at a maximum first, what happens? Your slopes are positive, then they are 0, then they go down, or something like that, right? So they must be positive, then negative afterwards. Do you agree? Positive slope, the negative slope traces this shape. Are you with me, guys? I see some people run away already. Yeah. So what do we figure out? So where do we have some change? Do you see at 4 positive above 4, negative after 4? So 4 is definitely a maximum. You see, this is the graph of the derivative. 4 is a maximum. Where is the minimum, please? None on the graph, a minimum, none on the graph. Let's look at this. Negative, then positive. Negative slope, then positive slope. You see, this is just representing slope. Negative slope means you're going down and then you're going up. Going down, going up. Do you see that it traces a minimum? Yeah, going down, going up. Going down, going up. So -4. Isn't it easy? Yes, guys? You see the slopes. If you what's a 0? 0 is not interesting to me. It's just the function. It has a derivative at 0. It just the derivative of the derivative doesn't exist. So 0. It's just this is the graph of slope, guys. You have to understand what it means, right? So you look at where the graph is positive. That means slope of my curve is positive. Yeah. So don't be confused. So this is of course correct. Do you understand, guys, how I did it? Yes, guys, this is just the graph of slopes, not the function. Here is another one. Please help me. You need to find maximum. Where is the maximum here, and where is the minimum here if there is one? And the rest of you guys, do you understand what we're searching? This is the graph of the derivative, right? So just those are slopes. So what should happen if you're climbing up a hill? If you're climbing up a hill, first you're kind of going up. Slope is positive, and then you're going down. Slope is negative. So you're searching a point where before that point you're going up, and afterwards you're going down. So you're looking at slopes, you see? So this means positive graph, this means negative graph in the picture. So I look, where can I have that pattern? Oh, here at 4, do you see? Positive before 4 and negative after 4. So 4 is and that's the only point I can see that does that. And what about relative minimum? Is there a relative minimum here? No, there is no relative minimum. I don't see any. You see, because here it's positive, then you rest at 0, then again positive. So you're climbing, you rested, then you continued climbing. So this is not a minimum, so there is no relative minimum. You understand? Relative minimum would mean that the curve is first negative and then positive. So the crossing is like this. The derivative graph crosses like this, relative minimum. Derivative graph crosses like this, relative maximum. Yes? All right, here is another one. Look at it. We're almost done, guys. It's already approaching question 30, right? We then have only more 20 questions left. So be strong. What do we have here? Suppose the only critical values of f prime are x at 10. That means the derivative is 0 is at 10, 20, and 30. And then we have f prime, and have this is the first derivative, second derivative. The question is, at 10, you guarantee what? So at 10, first derivative, second derivative is 0. Okay. So let's see what we can guarantee. Let's look at 20, for instance. 20, it's 0. The first derivative is 0, second derivative is 5. Which means what? Second derivative positive means the graph wants to become more positive. So you're at 0, and then you feel pressure to move up. So that means at 0, basically, so at 20, you have a local minimum. At 20, you have local minimum. Do you see why? Second derivative means that the first derivative is 0. So we're standing at some level point. Our line is like this. And second derivative is positive 5, which means if I move to the right, I will be tempted to move up, which means I'm at a local minimum. You agree? So it's a local minimum at 20. At 30, let's look at 30. At 30, I am at what, guys? 30, derivative is 0, and the second derivative is negative. So I'm tempted to move down, which means I am at a local maximum. And for this one, nothing. Do you understand? You understand how the second derivative is telling you something, guys? So first derivative is 0. Second derivative positive means the slope wants to change to the positive direction. So you're at 0, but the slope wants to go this way. Right? Which if you rewind before, the slope wanted to go this way too, because basically the slope is trying to be positive, more positive if it's positive here. Right? For second derivative, and if the second derivative is negative, you're at this tipping point where you want to fall down. Good? So it should be fast. Let's go on to question 30. Oh, here we have Francis, I think, left, but related rates. Okay, so let's solve it together then. So what happens here, guys? So when the radius is 3 feet, so we have a video of an expanding circle. So the radius is expanding, yes? The rate of the expansion of the radius is the RDT equal to 0.2. Yeah? So per minute, right? So feet per minute. So what do we have here? We want to know how fast is the radius, is the area expanding at 3. So we have area is pi r squared. So take the derivative of that, and you get 2 pi r dr dt. And so what do you put in here? We know r, we know dr dt. So we put 2 we put simply 2 pi and then times 3. We can just put it as 6. And then times 0.2. No. Here is another one. Height of an object is given by this formula in meters, seconds after the experiment begins. How rapidly is the object moving 5 seconds after the experiment begins? So 5 seconds. So all you do is take the derivative of this thing, right? And put 5. So that would be 10 plus 3, or 13 basically. It's 13. What does it want from me? This one, right? Seconds per meter. Okay. What? Meter per second, I mean. Yeah. Good? All right, here is another one. Spherical snowball is melting in such a way that its radius is decreasing at a rate of 0.4 centimeters per minute. At what rate is the volume of the snowball decreasing when the radius is 13 centimeters? So all you have to do, guys, is just, here is your formula for the volume of a sphere. It's 4 over 3 pi r cubed. Yes? All right, so I'm not even gonna even bother with this question, or should I? Maybe I'll bother. Fine. I mean, you see, so it's guys, come on. What's the difficulty, right? Radius is 13, 0.4 is how fast something is changing. So what you have is that dv dt equal to 4 pi r squared dr dt. Now r is 13 centimeters. Yes, r is 13 centimeters. So let's write it in. So we just write 4 pi 13 to the power of 2. And then what's the RDT? The RDT is 0.4. Yeah? Good? So it should, I mean, I hope the exam is more difficult than that. It's, my God, what is this, right? It's really such a low level. See, those questions are difficult, not like related rates in physics. They're not like this, guys. They're very difficult. You need to set up the problem and whatnot. So, all right, do this one. What's happening there? Only one person answered. Yes, I will upload it to the YouTube channel. Come on, guys. It should take you a few seconds to solve those questions, or minutes, I don't know. It's interesting, guys. Some of you know me well enough to know that as I'm bored with what we're doing here, I'm having a German war, right? German YouTube war. All right, finally. So let's solve this question together. So ship is 40 nautical miles due west. So west is here. So here is the ship. Due west of ship B. So there is ship B. So this is A. This is B. Ship A is selling. Ship A is sailing west at 18 knots, and ship B is sailing north. So this ship is going this way. This ship is going this way. So what do we have? We have this distance. So now, and then we have different distances. So you see, it's a right triangle. Yes. So ship A is selling. It's ship. So it's a bit different. So ship A is sailing west. Sorry, ship A is sailing west at speed of 18 knots, and ship B is sailing north at 24, right? Yeah. So how fast is it changing? At 5 p.m. It's so in 5 p.m. So that means that this ship is when, right? So first we have a distance between them is 40 knots, and after what? At noon, so it's at 5. So it's 5 hours later, basically, right? So 5 hours. So it's 18 times 5 in this direction, and it's 24 times 5 in this direction. So how fast is the distance changing? So what you do is this distance you can call E. So we have that E squared is equal to what? To x squared plus y squared. That's the distance, right? And what is that? What's x? So x is 18 plus times 5 plus 40 at that moment. So 2e prime is 2x x prime plus 2y y prime. So e prime. So basically e prime is x times x prime plus y times y prime divided by e. Yes? Now, so they just plug in the value for x and x prime, y and y prime, and e. E is root of this number. So let's write it all together. Hopefully we will not mess it up. So here is a ratio. What is x? X at that point is 18 times 5 plus 40. So let's say 18 times 5 plus 40. And that I have to multiply by x prime. X prime is by 18. Times 18 plus y is 24 times y prime is 24 times 5, I'm sorry, 24 times 5 is the value of y times y prime, which is times 24. Okay, and that entire thing is divided by square root of e, which is x squared plus y squared. What's x? So it would be 18 times 5 plus 40 to the power 2 plus what is y squared? It's 24 times 5 raised to the second power. Hopefully we did not make a mistake. Let's take a deep breath and see. We didn't make a mistake. Woo. Right, guys? It's not so hard, yes? Just shove those numbers in and we're done. Yes, let's go on with the next question. Okay, so can you solve this one? Or let's go and start working from the end. Okay, here is the end question, 50, guys. Solve this question, please. All right, are we done with this one? Let's see. Okay, how to solve it, guys? We have from 4 to 5, right? So what happens here? Do you see it's chain rule, right? It's just U substitution. So we just have 1/3 f x to the power of 3 evaluated from 4 to 5. And what do we know? We know that it is so it's divided. So it's this to the power of 3 minus this to the power of 3 divided by 3. Yeah. So let's put it in. So the bottom is 3. The top is 10 cubed minus 3 cubed. Where did I make a mistake? Is it a minus? Yeah, it is, probably it was equal sign, right? So that I wrote or something like that. Good. Previous question. What is that? Quickly, guys. I mean, it should take you 2 minutes maximum. Okay. Tell me what it is in 2 minutes. All right, finally, somebody wrote something. God damn it, right? So this is ln. Where are the functions there? Functions ln of 9 minus ln of 7. Right. Sorry. Right. So it's f this crop, right? So it's at 9 it is 3, and at here it is 6. Good. Here is another, guys. Come on, could you speed it up? Let's finish this. Let's just be done with it. Just 15 or so more left, and we're done with the entire review. All right, so somebody wrote something. Let's see. So this is sine of what number? So at 9, it's -8, minus sine of at 6, it's 1. Come on, this one fast. All right, this, guys, we haven't yet, I didn't teach you that yet, but it's in my notes and in the video if you looked at it. Okay, so this is what? So f, first of all, f of 6. What is f of 6? Is the integral of this entire thing from 6 to 6. Now, because 6 to 6 is 0 interval, so this would be 0. F prime of 6. You take the x and you drop it here, so that becomes 1 plus x to the power of 4. Incomplete? What's incomplete about it? I don't know. All right. It is at 6, so I should put 6 there, sorry. Here at 6, g of 6, this would be, again, this function at 6 is 0, so it's 0. G prime of 6 is just chain rule, so it would be, sorry, product rule, right? So it's this over that. Not particularly exciting to do it. So it would be as follows, right? So it would be this derivative at 6. So it would be root 1 plus 6 to the power of 4 divided by 1 plus 6 to the power of 5 plus 0, pretty much actually for 0, so it's very nice. Okay, good. How to do that, guys? You need to look at my notes. I will try to teach it on Tuesday and Thursday, those questions, okay? But before that, try to look at the notes. This is something we haven't yet talked about. Notes or videos? Okay, here's another one. Can you solve this one quickly? Yes. All right, too bad, guys. See you, Jeffrey, then on Tuesday. All right, and the answer is what, guys? Just integrate this function and plug 4 and 3. So what do we have here? Let's put parentheses here. So the antiderivative of x squared is 1/3 x cubed. Yes, and we plug in 4. So it would be 1/3 times x cubed, which would be 4 cubed, plus 3 times the integral of this function at 4 is minus 10. Minus 3 times 4. And then that way, from here we subtract. And let's copy this thing. Can we copy? Force me to write this code. So so then here we have 1/3. 3 cubed plus 3 times 1 minus 3 squared. Yes, here it is. 1/3. Good. It only takes the only time it takes is to write it in. What about 45? Continuous and positive from 4 to 17, increasing from 4 to 17, right? And then we have this information and that information. So f of 9? Look at it, guys. It's an area. That's still something that you would understand if you read more about the integral. The area is from 4 to 17 is 86, and from 9 to 17 is this. And they're asking me about f of 9. Between what values can it be? So first look here. It's increasing, right? So f of 9 is increasing, so it's less than the value at 17. Positive. So then we can take this number from 9 to 17, which is 56, and divide by the difference of 17 and 9. So 17 minus 9 is what? It's 8, right? So this number I would write as 56 divided by 8. And here, as an upper estimate, I just can take 86, subtract, so it's at 9. So from 86, I subtract 56. And divide by, and then so if I subtract 56, it's now from 4 to 9. So here it would be 9 minus 4. Here we go. Did you understand what I did? No? It's fine. That means you need to know integration better. That means you need to look through my notes. I will not explain it now because I haven't covered it. Okay, so Tuesday, Thursday, we're going to talk about it. But look at my notes for integration. Do you know where we are, right? Read those notes if you understand what integration is, and then it should not be too difficult. So we will do a lecture on both Tuesday and Thursday. Still, there will be a lot to catch. Okay. And this is a very similar question. Okay, I'm gonna skip it for now. Same ideas, same questions. You need to get integration better, to know integration better. This is Riemann sums where you need to know integration better. This is also integration questions. All right, guys. So you know what? You see, and then we are already at some place where we're almost there, right? So I think let's talk about those questions perhaps after we have read integration. Maybe on Thursday we will. It might make better sense to review the integration questions then, once we have talked more about those ideas. Again, guys, I cannot emphasize enough that you should look into the math 150 and look at the lecture notes. So make sure to read the lecture notes for integration. This is what you need to know. Yes, all of this, guys. We have a little time. So today, if you can, tomorrow, whatever time you have, read those lecture notes and we will talk about it on Tuesday. David, you are morning or evening? Remind me. Morning, right? So morning, it's on the 21st. Yes, 21st, and the evening it's on the 25th, I believe, right? So it was messaged in an email before. I will probably message it a few times again. All right, guys. Thank you for coming. I hope. And if guys, another thing I forgot to mention: if for some reason you have a schedule conflict, you need to email Professor Jeff Suzuki. He's controlling the finals and those exams. So email Professor Jeff Suzuki and mention you're from my class and mention what problem or conflict you have, if you have one. Good?
Yeah, but the night, like for Tuesday and Thursday class, aren't we taking it on Friday, like 2 to 3?
But I think you misunderstand. It's for evening students. It's the 25th.
What time?
At 6 to 8, I think.
25th. Okay.
25th, 6 to 8. I will message it again. You see, so a morning class is running a different schedule. Evening classes are taking it from, I believe, 6 to 8. Okay. So I send an email about it. I hope you receive it. I will send those emails again. So it's a different day altogether. Well, no worry, Jahin. Nice that you are trying to come here. So guys, we are going to work, and thank you, Humira, for staying so long. We're going to work Tuesday and Thursday intensely, but guys, even with 2 extra lectures, I cannot thoroughly cover lectures. We covered a few of those. We're roughly in here. This is a bit intense, right? So we need to cover all of it. We covered some of them only. You need to read it, and you need to have a good comprehension of integration. Good? Try to help me achieve that good comprehension before the exam. Yes, on the test grades, well, my update is that, I force myself to grade and look at it. That's my update. Yes, which I'm going to be doing today as well after we're done. All right, guys. So besides, second exam, you received 100. Final is essentially the only thing that you are doing. So it should be, hopefully it's going to be good. Okay, so prepare, guys. You should solve those questions in a minute. Good. Take care. Have a good one. Enjoy the rest of your weekend. Goodbye. No worry, it's okay, Sophia. When you have time, you get it, okay? Take your time if you need more. So I think you can just, you have those questions and I'm not sure how many times you can go back. I'm sure that you can submit your work if you have it. With internet, I hope it will not be kicking you out too frequently, right? We'll see, Jahin. Don't get worried about it. If something happens, you let me know. At least I know you're a good student. I will help you. Okay. So if in your case, Jahin, especially since you have those, I know you're a good student. I trust you. And if anything happens, you can just have those questions written on a paper, and I will look through the paper. But let's hope nothing happens. Okay. So don't panic, no reason. So I do not know how many questions, definitely not 50. You need to show your work. The work you show on a separate piece of paper, which you then submit through this My Open Math. If the internet fails you, I will look at your solutions. All right, any other questions? Anything I can help you with, guys? Yes, yes. If you could, ideally it's on the website, so it will be easier. But if not, in your case, especially Jahin, I trust you, so I'm going to look at it for sure. No, don't worry, it will be okay. Relax. Just know the material, right? Just that's all you need to do. Know the material. If you can answer those questions, then that's fine with me. We'll figure it. All right. Miriam, Dauda, any other questions? Jahin, any other questions? All right. Goodbye. Take care. Take care, Jahin. Dauda, are you here? Mariam, are you here? All right, I presume you're not here, so goodbye, guys. Dauda, any questions? All right, then goodbye. All right, I removed Dauda. And stop the recording, of course. It's not stopped. 1 second. What the hell is going on with this?